up agreeing. So number one, believe it or not, number one is something that we did for the first time last August.
No way.
And so if you're remembering this today, January 8th, it's awesome. It's really, really good. If you're not remembering it, that's why we're doing this, to get you to remember a little bit more. So here we go. First thing I would do is I would replace all of the variables with empty parentheses, and it would start off looking something like that. And then inside those empty parentheses, I would put -1 because that is the x value that we're supposed to be using to evaluate. And then I'm going to try to follow my order of operations. So there is no work to be done in the parentheses, but there are exponents, right? Mm-hmm. So there's one exponent, I guess. So what's -1 in the parentheses squared?
1.
It's 1. That's right. So it'd be 3 times 1. And then I'll just continue on with this, I suppose. And then we're going to do our multiplication now that we've done our exponents following that PEMDAS pattern. So, of course, 3 times 1 is 3. What about that second term? What do you get for that?
Positive 9.
It's +9, yeah. So +9 plus 2. The only thing remaining is just addition. 3 plus 9 is 12 plus 2 gives me a final value of 14. How you feeling? Good? Any questions? Okay, number 2 then. Number 2 says simplify. This is something we did more in the middle of last semester, so a little bit more familiar. Do you guys see the 2 distributor properties in this that we really have to do first? Mm-hmm. Okay, so the 9 gets distributed throughout, and so I end up with 36x squared minus 9x plus 63. And what's being distributed on the second term?
-5.
Say again, Ben? It's -5, right? It's not just a 5, but the negative gets distributed as well. So the negative gets distributed to both, so it'd be minus 5x squared. Almost nobody ever misses that part. What do people miss on the second term? It's got to be plus, right? Because a negative times a negative is a positive, so it'd be plus 10x. And then I'd go through and add my like terms. I've got a 36x squared and a minus 5x squared. That gives me 31x squared. I've got a minus 9x and a positive 10x. That gives me plus x. And, of course, the 63 doesn't have any term to be like it. So that would be our final expression. Questions, concerns? We all doing okay? Fantastic. All right, so then number 3, we're supposed to solve and graph. Did you notice the 2 terms on the left side that could be combined? 3x and the negative x. Okay, so if you combine those, you get 2x plus 5 is less than or equal to x minus 4. And we run into this issue here. We're trying to simplify this. Of course, there's an x on the left side. There's an x on the right side. What do I need to do to get those 2 x's together? What would you suggest? Subtract what?
X to the one side.
Okay, so subtract x over here from both sides. So that would give me 1x plus 5 is less than or equal to -4. By the way, this is an important question. Should I be flipping the inequality around? Because I did just subtract x from both sides, right? Why not? It's when you divide or multiply by a negative, right? It's not when you subtract. Yep. So I need to leave the inequality as is. My last step would be to subtract 5 from both sides. So I end up with x is less than or equal to -9. What do you guys think of that? Any questions on that part so far? We're all good there? Okay, and so then on the graph itself, I'll put -9 over here. Obviously, it's not labeled, so I'll just put the -9 right there. What kind of a circle do I put over that -9? It would be a closed circle because of the or equal to. And I've got to draw an arrow either to the left or to the right. Which one do you think it is? Left. Arrow left, because we're looking for numbers less than or equal to -9. Okay, so there's 1, 2, 3 right there. Did it bring up any questions for you? If it did, it would be totally understandable because I'm guessing that you all probably didn't do math every single day over Christmas break. Was it just every other day?
It was 0.
Was it 0 days? No, I'm just kidding. I'm assuming that you probably didn't do any math. And so if you forgot some of this stuff, it would be totally understandable, wouldn't it? It's been like, 16 days or so since you've done anything like this? If you're remembering it, that's fantastic. If you have a question, that's great.
In your final answer, does x always have to be on the left side of the equation in
Nope.
order to graph it correctly?
Well, no, not really, because so it could look like this. I certainly prefer it this way,
I wrote it the second way.
but this way is really saying the same thing.
It's
In
just
my
like-
opinion, it's a little tougher to get it to graph right if it's not written in what I call kind of like that standard form, like that I have in the box up there. But on that thing that I have underlined up there is totally correct. I would
So
never mark
if
that
I
wrong.
wrote that for my answer, but graphed it going the wrong direction because that's
Yeah,
the
you'd
way-
get like half credit or whatever. You like wouldn't get credit for the graph, or maybe you get half credit for the graph because maybe you had the filled-in circle or something.
Yeah.
Yep. So either way works. Yep. Anybody else with a question, concern at all? Okay, so the last one might have been the toughest one. What's a key word that jumps out to you as something that tells you what to do, but is also sort of a challenge as well? Perpendicular, right. That word is always a challenge. Of course, I was talking about it over here with Noel. The word perpendicular starts with the letter P, and the word parallel, which is very different from that word, also starts with the letter P. But since they both start with the letter P, it's easy to mix them up. So parallel lines, so not this, but parallel lines have like what kind of a property? Or what could you say about parallel lines? Parallel always or never?
I was going to say same slope, different points.
Same slope, different points. That's true. That's true. Parallel lines
They will never intersect.
never intersect each other, right? Perpendicular lines for sure will intersect each other because their slopes are different, and specifically opposite and reciprocal. Good. Okay, so we've underlined that word, really key word to understand here. We kind of read through the rest of this. It says, write an equation in slope-intercept form. That's pretty important. Of a line that goes through this point and is perpendicular, we already talked about that, to this line right here. Okay, so let's think this over. We talked about this over and over first semester, but it has been several weeks. If I'm going to try to write the equation of some line, I got to have two things. What are they? Point on the line and the slope. Well, the good news is I've got the point that's on my line right there. Sorry, that was a bit much. There's my point. And my slope, not as clear. So let's go back to what you guys said earlier. You said that perpendicular lines have opposite reciprocal slopes. So what's the slope of this line right here? 2/5. So what is the slope that I want? -5/2. Yep. So that's the opposite reciprocal. Opposite and reciprocal slope. So my point is going to be -2, 7. And my slope is -5/2. I'll take a minute here because we'll be able to finish this, I hope, hopefully relatively easily here. Let's make sure that we understand where we got that information from. Does it all make sense? Again, it wouldn't be totally understandable if somebody was like, whoa, I totally know we did this first semester, but I'm feeling a little confused as to where we got the whole -5/2 or whatever. Anybody feeling that way? I would definitely get it. Okay, fair enough. So did you guys use point slope to get this started? That would be what I would suggest. So I would write y minus 7 equals -5/2 times x minus -2. So that's your point slope form of a line. Make sense? Okay, of course, minus and negative is really plus a positive. But this asks us to go to slope-intercept form, and this is not slope-intercept form. What might I need to do to take this from point slope, which it is right now, to slope-intercept? Distributive property? Sure. So distribute this to here and here. Y minus 7 then equals -5/2 x. What is -5/2 times 2? It is -5. -10/2, same thing as -5. And my last step would be to add that 7 over. So did you guys get this for a final answer? Y equals -5/2 x plus 2? Sweet. Okay. So I sincerely mean this. I hope you understand that. You've been like 2.5 weeks about since we've done anything like this. And so if you got most or all of these right, or even if you only got half of them right, but you were just like off by a little detail, that's awesome. It's really, really good. We'll practice this again, of course, tomorrow before we do any kind of a DMR quiz. Hope this gives you some confidence that you're retaining this. It's really, really good. Okay, any questions at all? Okay, sweet. So I got kind of a problem to pose to you here, like a very real life problem. And it's right here on the next page. So if you haven't already read through this, go ahead and read through this with me. I'll read it out loud. It says, Bob is constructing a wall for an addition to his house. He has measured the base length to be 16 feet long and the height length to be 10 feet. How long must the diagonal be if the wall is supposed to have only right angles? Let's talk about this really quick. Why would Bob want the wall to have only right angles? Yeah, so it's straight up and down. Not too many houses have walls that are like leaning one way or the other, at least not a well-built house, right? Wouldn't that be a concern if you came home today and you pulled up to your house or whatever, your mom, your dad, whoever, and your house wasn't like this, it was like this? Wouldn't that be a little concerning? I would think so. And so Bob wants his house to be straight up and down. So he's measured the base length to be 16. Hang on. Measured the base to be 16, the height to be 10. So we are talking about this and this. I'm wondering if you guys can come up with any ideas. If we want this wall to be only right angles, how long would the diagonal need to be? So the diagonal, of course, we're talking about the distance from here to there. What could we do? Find the area divided by 2. So what's the area of a triangle?
Base times height divided by 2.
So area equals 1/2 of base times height. Okay, so the base is 16, the height is 10. Now hold on just a second. In order for this to be a valid formula, what does the relationship have to be between the base and the height?
Same.
No. In order for the height to really be the height, we do this at my house. You guys probably don't do this anymore. But at my house, we have a little wall where we mark my kids' height because they're really young, and so it's probably bad because the board's back here. But you know, when we have them stand up against the wall, of course, my little 3-year-old, when he stands up to the wall, he like does this. And what do we tell him? Stand up straight. And so he stands up, and it's hard for him to hold still for very long, you know. So he does this, you know. And he's just sitting there fidgeting and doing all this stuff. We're like, hold still, just hold still for 1 second, right? So this would be like his true height, wouldn't it? Why would this be his true height when this isn't?
Straight.
Something more than just straight, because isn't my body straight right now? Say again? Yeah. Why is this not my height? My body is about as straight as I can make it.
Angled.
It's angled, right? And now my body is vertical. And when we're talking about vertical, what kind of an angle are we talking about?
90 degrees.
So the problem with this strategy of height is we're already assuming that we already have a right angle. And so I don't think we can really use this formula because we don't know for sure that the 10 is really vertical, right? That's what we're kind of trying to prove here, aren't we? We're trying to determine, hey, is the 10 really straight up and down, or is it leaned over? Right? So I don't think we can really use area here because that's presupposing that we already have a vertical side, and we don't know. So keep thinking. What else could I use here? This is something that I'm pretty sure you covered in middle school. I could be wrong. Yeah.
A squared plus B squared is equals C squared.
And what is that?
Pythagorean theorem.
Pythagorean theorem.
Yeah.
So the Pythagorean theorem is unique because it only works on what type of triangle? A right triangle, one with a right angle. That's right. So if I were to label that diagonal, maybe I use the letter C, like Josh mentioned, then that relationship of A squared plus B squared equals C squared should be true if I have a right angle. So here we go. I would say maybe something like 10 squared plus 16 squared is equal to c squared. Does that make sense based on what Josh brought up? Okay. We do a little arithmetic here. What's 10 squared? 100. What's 16 squared?
256.
It is 256.
I already did.
Okay, so then of course you add up the left side, you get 356 equals c squared. Here is where kind of our new concept for today comes into play. Here's why you would maybe care a little bit about this. If I'm trying to figure out c, I've got a little issue because I've got c squared sitting right there, but what I really want is c. So what do I need to do to make the c squared become just a c? How do I get rid of the squared part? Square root. That's kind of our newish concept today. I know you've probably seen a little bit of this before. We're going to explore square roots. So what I would do here is I would square root the left side and the right side. Square root both. So we're going to find that the square root of c squared, the positive square root of c squared is just c. And now we're going to talk about this today. We won't really need the calculator too much today, but maybe on this one we will because I don't think 356 is a perfect square. So it's going to come out to be some decimal number. So if you've got a calculator with you, take a minute, see if you can figure out what the square root of 356 is, and we'll know what Bob's Wall's diagonal should be. Square root of 356.
Yeah.
18.868. Does that make sense? Rounded?
Yeah.
Okay. So here's what this means. This means that if Bob gets out his tape measure and he measures from this corner to this corner, if that measurement is anything other than 18.868, that means that this angle down here is not a right angle, and he's got a little problem, and he needs to knock that wall over a little bit, and so that the diagonal becomes the appropriate length. Right? Question?
Is there any case where you would want to change 18.68 to 18.9 and just round up, or would that make it wrong?
It just depends on how precise you want to be. Right? So, somebody might look at this and say, well, gosh, my tape measure only has inches and quarter inches, and how precise could I be? And maybe you do round it, and you're like, okay, this is halfway between 18 and 3/4 and 19, and you do your best. It's interesting, if it's like a foundational wall and you're off by a quarter inch, does that translate into a half inch later, and then an inch later, and then somewhere down the road, when you get to 200 feet tall, is it a foot off? It really depends on how precise you need to be. So if you need to be really precise, maybe you use something other than a tape measure, maybe some laser measurement, something like that. Yeah. And by the way, did you know that a large building like this, or maybe a large building like a house or something like that, the way that they make sure that the building is actually square is this. You ever thought about that? So this big building here, Valor, when they made the foundation, the corners on all the corners of the building, all these corners, they're right angles, right? Wouldn't it look really dumb if it was 10 degrees off or something? Have you ever wondered how on earth do they make sure that it's really a right angle? Do they have a huge protractor? This 50-foot long protractor, and they have this crane come and set it down, and they're all right, 88 degrees, let's move it over 2 degrees. Come on. You know what they do is the Pythagorean theorem, but they probably use lasers to actually measure stuff because they don't have tape measures quite long enough to stretch all the way across the diagonal of a building like this. They're just going to shoot a laser across to the corner and be like, whoa, we need to change the angle on the forms of our, for our foundation, for the concrete for our foundation, move it around a little bit, remeasure the diagonal. Hey, look. And this is where Chase's idea of how precise do you need to be. Maybe they get it down to the millimeter or something like that, and they say, hey, you know what, the building's square. We can now build on this building, and it won't look stupid or fall over, whatever. Okay. Anyways, so I share this with you simply because we're going to be talking about radicals. We're going to be talking about square roots, those kinds of things here, and hopefully maybe this will give you a little understanding of where this could come into play. All right, so let's take a look at a few concepts, and I just have a handful of examples today. So looking specifically at square roots, Let's see if you guys can answer a couple of these questions. A square root is the inverse or opposite operation of what? Squaring, yeah, of squared. Yep. I'll just put it like this. It's the opposite operation of squaring something. So if you square something and you want to reverse it, you just do a square root. It's the opposite operation. Anybody explain what that means? No? You're kind of telling me a little bit about how I might do this one. I'm just wondering, like, what does it actually mean? Joe?
What times what equals 25?
Really close. Super close.
What number times itself equals 25?
Super close. You guys are saying really similar things, and you're both like right there on the edge. There's one little tiny thing we need to add to this.
Square root of 25?
And again, that's a good explanation. They're going a little bit deeper, saying, hey, what times what, or what number times itself is 25? But you guys are all correct. You're not necessarily wrong yet. There's just one little detail we need to add, and I'll put it in here for you. It's this. What positive number times itself is 25? What positive number times itself is 25? What's the answer? 5. Yep, so the square root of 25, as Noel correctly pointed out, is what this, another way you could say this. The square root of 25 is simply 5. What positive number times itself is 25? The answer is 5. Have you guys ever heard of the parts of these, like what the names of these things are?
No.
Okay, so this, the little check mark looking thing, little check mark, whatever, maybe you want to call it that, that is called a radical. And it might be tempting to think that, well, hey, they're all square roots, and so why don't we just call it a square root? The truth is there's more than just a square root. There's cubed roots, there's fourth roots, there's fifth roots, blah, blah, blah. There's all these different roots you could find. The square root is probably the most common, for sure at this point. But because it could be all kinds of different roots, we just call it a radical. And then I'm going to be super impressed if anybody knows the name of the n. So close. I agree with that part. I think we differ a little bit at the end. We might be just saying it differently. Radicand is what that is. Radicand. He was very close. Yes.
Did you totally guess that?
No, I just learned it last year.
I was going to say, it was probably like in your brain from last year somewhere.
like-
Yeah.
How we?
Okay, so the radicand is the expression that you're finding the square root of, right? So earlier the 25 was the radicand. Anyway, so that's just a little bit of terminology. Let's do a handful of examples here, see how it all goes, and then I think I'll be done with presenting stuff. Okay, so please check these out. Okay, so number 1, square root of 121. So just like we pointed out earlier, this is asking you a question. It's saying, what positive number times itself is 121? If that's, you probably should recognize that. If that's you, just go turn it off. What do you guys think?
Who wrote the debt school?
Hey guys, I know it's a phone. We all have seen them before. What do you guys think? What positive number times self is 121? 11. That's correct. So something like this, I don't know that I would expect on a question just like number 1 here, I don't know that I'd expect you to be showing a ton of work. If you wanted to, you could. You could show a little bit of work. But if you just knew that 11 times 11 is 121, you just said, hey, the answer to that's 11, I'm good. I'm good with that. Okay. Any questions on 1? Okay then, so number 2, a little bit different. Obviously there's a fraction there, but you guys see the negative out front? So that means that our answer in the end is going to be negative. We just have to ask ourselves, what positive number times itself is 16 ninths? You can do it separately, yeah. What would you think if we were doing it separately?
Well, because I know 4 goes into 16.
So what positive number times itself is 16?
4.
What positive number times itself is 9?
3.
Negative 4/3. So you can do it separately. But if you think about it, 4/3 times 4/3 is just 4 times 4 over 3 times 3. It's the same thing, 16/9. Okay. So we're gonna delve a little bit deeper here into some expressions with variables. And this will maybe push you a little bit further, which is a good thing. We'll explore these a little bit more tomorrow. But think about it like this. Earlier I said, what is the square root of 121? And you all thought, all right, what positive number times itself is 121? You all came up with 11. Good. So here in number 3, it's the same thing. I'm asking you what times itself is a squared. What do you think the answer would be? A. A times A is A squared, right? Like that's the meaning of what A squared is. So what number or what expression times itself is A squared? The answer is A. Make sense? You guys have any questions on that one? Okay, let's go a little bit deeper. Take a look at number 4. This one is not the square root of A squared. It's the square root of x to the 6th. So it's the same question. What times itself gives me x to the 6th? Any ideas?
X.
X to the 3rd is right. Let's explore this a little bit. It's going to be laying some good foundational stuff for what we do here in the future. So the answer to this is definitely x to the 3rd. But let's check this and see why this works. Okay? So if x to the 3rd times x to the 3rd is really x to the 6th, I should be able to check it doing that. So see what happens here. So if I take my answer and I say, all right, well, let's check this. X to the 3rd times x to the 3rd. Well, what is x to the 3rd really? Like what? Yeah, it's x times itself 3 times. So it'd be x times x times x. And of course, the other x to the 3rd is the exact same thing. So it'd be x times x times x. How many x's do I have multiplied times each other? 6 of them, right? 3 x's multiplied times 3 other x's. And so I've got x to the 1st times x to the 1st times all these x to the 1st. Well, if I got 6 x's multiplied together, what is that? Isn't that x to the 6th?
Yeah.
So this would be x to the 6th. I check it with this. It does check. That tells me that x to the 3rd would really be the square root of x to the 6th. Does that make sense?
Amazing.
Questions?
This is a movie.
Okay, so then the last one is 49, square root of 49r to the 16th. Why don't I leave this one up to you to try on your own? See how it goes. We've established some patterns here. Hey, listen, if you don't have this down perfect right now, that's not a big deal. I just want you to try it. If you succeed, fantastic. If not, it's okay. Let's look at some thoughts here. So I peeked over, I think, just about everybody's shoulders, and I think every single person in this room has at least one common element on all their answers. I think every single person has 7 as part of their answer. Doesn't that make sense? Because 7 times 7, 49, right? Hey guys, please don't let that be a distraction. Just a phone. So the fact you have 7 in there is good news, right? So then I saw 2 varieties of answers. I think I only saw 2. I saw 7r to the 4th, and I saw 7r to the 8th. Those are the 2 answers that I saw. And so it's got to be one of those 2. Either one of those is correct, one is wrong. So the way that we could check this, I'm not too worried about the 7 because 7 times 7 is 49. I'm concerned, of course, about the r to the 4th and the r to the 8th. What I should be able to do is I should be able to take that r to the 4th, I should be able to multiply it times itself and get my original. So here's what it would look like. I'll check the r to the 4th first. So it'd be r to the 4 times r to the 4. Isn't r to the 4th really r times itself 4 times? So it'd be r times r times r times r times 4 of them for the other one. Now how many r's do I have being multiplied times themselves? 8 of them. So that is r to the 8th. Does that match my original radicand?
It does not.
It does not. So this is a problem. That means that r to the 4th is not the square root of r to the 16th. If I look at the r to the 8 and double check that, this will be a little bit tougher because there's a lot of them. So this will be 1, 2, 3, 4, 5, 6, 7, 8 of them, I think. Yep. Times 1, 2, 3, 4, 5, 6, 7, 8. 8 of them. What is 8 r's times 8 r's? How many r's are there?
16.
Ah, that's it, isn't it? So this would be r to the 16th, which does check with this. So that tells me that 7r to the 8th is my correct answer. Does that make sense? I'm trying to help you with kind of the back way of checking it to help you understand how it's supposed to work out. We'll do a lot more work with this tomorrow. Okay, so I think we got about 10 minutes left here. We're going to do a little bit of work at the board. So here's how I would like to do this. We'll split this in half. I just want to kind of intro this for you because we just did a very little bit of this first semester. Let's get Nick's table and Irene's table to go to, I don't know if you all fit here at the front. Either board works for me. There's not very many markers back there, but go ahead and stand up, go to the front board. You guys will get to go next. Just, you guys, just 2 tables. We'll get these guys to go next. So you guys, for now, you can practice along with them. You can watch, see how they do, check answers. It's not a race right now or anything. I just want you to go to the board. Just going to see how you're all doing.
I just got a random song stuck in my head.
I don't feel so good, Mr. Stark. I don't want to go. I don't feel so good.
I found the music for that song. I'm sorry. It's so weird.
All right, ready, set, go. See if you guys can do that square root. Square root of 64, y to the 6th. Square root of 64, y to the 6th. Stuck on the r's from last one. Yeah. It's all good. I do the same thing.
How would 8 r?
Unacceptable.
Hey, you guys all see, you guys agree, folks that are sitting here, 8y cubed, is that right?
Yes.
8y cubed is correct. Let's try another one.
Alrighty.
That is good.
What is that? It looks like a Chinese song. I don't want to go to Hibble.
Okay, we'll try one more for you guys at the board right now.
Yeah, it's Bible and history.
Hibble.
Square root of 81, x to the 10th.
Okay, I think it's funny. You look at Whitman and then you look at Mariah. Look at the size of the writing.
I know, it gets like
Yeah, it gets steadily smaller.
That's so
I like it. I like it. Hey, I am feeling encouraged. I feel like folks at the board, as of right now, have a pretty decent grasp of this. Great job. Let's switcheroo.
You guys are great.
Get the chair, get the chair.
No, them, us, we're gonna get started. Yeah. What are you doing? What do you mean? I'm just going to the back. It's all right. It's all right.
Yep, number 3. If you're at the board, please do number 3. Square root of 144, a to the 4th. Fantastic. 12a squared. Very good. Hey, let's see. Hey, folks that are sitting at the tables, let's see if you can do this one too. I'm going to push them a little bit further and see how this goes. I bet they can still do it. I bet you can do this too. But let's try this one. Let's go square root of...
What do you mean?
Callie, you okay? Started squaring.
Square root of 9y to the 200.
What?
Square root of 9y to the 200.
Oh, I thought it said 300. Oh my god. You're just so big all of a sudden.
Hey, you guys are doing great.
The whole board.
3y to the 100th
About the same size.
is correct. Great job. All right, come back to your seats. Good job.
Can we go back up now?
5